In this episode, we are looking at a group of cloud ideas that sound very abstract when you first hear them, but they become much easier once you connect them to what users actually notice during the workday. A user usually does not say that elasticity failed, availability dropped, multitenancy caused a problem, or synchronization was delayed. Instead, they say the app got slow, the service stopped working, the file on one device does not match the file on another, or the system acted differently today than it did yesterday. That is why these concepts matter for a beginner technician. They describe how cloud services behave under real use, how those services stay up, how many customers can share the same environment, and how files stay consistent across devices. When you understand these ideas in plain language, cloud support becomes much less mysterious because you stop seeing cloud as a distant thing in somebody else's data center and start seeing it as a set of behaviors that directly affect what the user can do, when they can do it, and how reliable that experience feels. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A good place to begin is with a simple support mindset. In a traditional local computer problem, the technician often starts by looking at one device, one user, and one direct cause. In a cloud environment, the experience can depend on shared infrastructure, remote services, internet paths, account status, and how the service is designed to respond when demand changes. That means a user may be doing nothing wrong and still see slow performance, delayed updates, or strange differences between devices because the service itself is behaving in a certain way behind the scenes. For beginners, the important lesson is that cloud support is often about understanding service behavior, not just device behavior. A system can be working exactly as designed and still feel confusing if the technician does not understand why the service grows under heavy demand, why files take time to appear elsewhere, why shared infrastructure matters, or why a brief outage in one part of the environment can affect many users at once. Elasticity is one of the most useful cloud concepts to understand because it explains how a service responds when demand rises or falls. In simple terms, elasticity means the cloud service can add more resources when it needs them and reduce those resources when demand becomes lighter. A beginner can think of this like opening more checkout lanes in a busy store and closing some when the rush is over. The goal is not to keep every possible resource running all the time. The goal is to have enough power when many people need the service and to avoid wasting resources when they do not. That matters because cloud systems are often used by changing numbers of people at different times of day, week, or season. If a service is built well, it can respond to that change more smoothly than a fixed system with the same amount of power at every moment. And that gives users a better experience when demand suddenly grows. It also helps to connect elasticity to scalability, because beginners often hear those words together and assume they are exactly the same thing. Scalability is the general ability of a system to handle more work as demand grows. Elasticity is the more active behavior of adjusting resources up or down as that demand changes. A service can be scalable in principle because it is built to support growth, but elasticity is what makes that growth more dynamic in real use. For support work, the difference is helpful because it explains why one cloud service may survive a rush of users better than another service that can support growth only with more manual planning. A technician does not need deep architecture knowledge to benefit from this idea. What matters is recognizing that some services are designed to stretch and shrink more gracefully than others, and that graceful adjustment can be the difference between a busy day that feels normal to the user and a busy day that turns into widespread slowdown or complaints. You can see the value of elasticity most clearly when many users arrive at once. Imagine a school portal during registration, a business payroll system on payday, or a public-facing app during a major event. If the system can respond to the sudden increase in activity, users may notice little more than a brief delay or no delay at all. If the service cannot adjust well, users may see long waits, failed logins, missing pages, or timeouts that make the whole platform feel broken. A beginner technician should notice that the user does not care what the cloud platform had to do behind the scenes. The user only sees whether the service stayed usable when demand grew. That is why elasticity matters so much during support and troubleshooting, because if the problem appears mainly during busy times and becomes less noticeable later, the issue may not be a local device failure at all. It may be the service struggling to respond smoothly when too many people are asking for the same thing at once. Availability is another major cloud idea, and this one is easier to grasp because it connects directly to whether the service can be used when people need it. In plain language, availability means the service is up, reachable, and functioning well enough for normal work. Users do not usually think in terms of availability percentages or service design. They think in terms of whether they can sign in, open the app, save their work, and trust that the service will still be there after lunch or the next day. That makes availability a daily support concern, not just a big-picture planning term. A service with high availability is designed to reduce downtime and keep working even when hardware fails, traffic changes, or maintenance is happening somewhere in the environment. For beginners, the important lesson is that availability is not just a technical brag. It is the reason users feel a cloud service is dependable instead of fragile. Cloud providers work toward availability by reducing single points of failure and planning for the fact that parts of the environment will eventually break, restart, or need updates. That may involve duplicate systems, load sharing, automatic recovery, and careful placement of services so one failure does not take down everything at once. A technician does not need to design those systems to understand the support impact. If a service has been built for strong availability, a local fault somewhere behind the scenes may never be visible to the user because another part of the environment continues the work. If availability is weaker, then one failure can quickly become a service interruption that affects a large number of people. This matters during troubleshooting because technicians need to think about the difference between a user problem and a service availability problem. If many users in many places are reporting the same outage at the same time, the issue is probably not on one laptop or one desk. It is more likely a service-side problem affecting the cloud environment more broadly. Availability is also important because not every outage looks dramatic. Some services do not go fully down. Instead, they become slow, partly functional, or unreliable in ways that confuse users and beginners alike. A person may be able to sign in but not open files, or may reach the app homepage but fail when trying to save work, upload data, or access one specific feature. That kind of partial failure can be harder to understand than a full outage because it creates mixed signals. Some functions appear normal while others fail, and the user may describe it as the system acting weird instead of the system being down. A technician who understands availability will know that cloud services can degrade instead of simply stopping. That means support work includes watching for patterns, such as multiple users reporting the same limited feature failure, which can point to a broader service problem even when the platform still looks alive from the outside. Multitenancy is one of the cloud ideas that sounds the most unfamiliar to beginners, but the basic meaning is very simple. It means one larger cloud environment can serve multiple customers or groups while keeping their data and activity logically separated. A good beginner way to picture this is an apartment building. Many people live in the same building and use the same structure, plumbing, and power systems, but each person still has their own apartment and their own private space. In a cloud environment, multi-tenancy allows many customers to use the same underlying infrastructure without each one needing a completely separate physical setup. That helps providers use resources more efficiently and keep services more affordable and flexible. For support work, the main point is that a user may feel like they are using their own service space, but behind the scenes they are often part of a larger shared system built to separate customers logically rather than by giving every customer completely separate hardware. The reason multi-tenancy matters during support is that shared infrastructure changes how problems can appear. On the good side, shared infrastructure can make services cheaper, easier to scale, and easier to update because improvements to the environment benefit many customers at once. On the difficult side, the service must be designed well so one customer's activity does not interfere too much with another customer's experience. Beginners sometimes hear this described with ideas like a noisy neighbor, which simply means one tenant's heavy use can affect the shared environment if the service is not managing resources well. A technician does not need to become a cloud architect to use this idea. It is enough to understand that some cloud services are shared under the surface, which means performance patterns, temporary slowdowns, or maintenance behavior may come from the shared design of the service rather than from anything the user personally did on their own device. Multi-tenancy also matters because it places a lot of importance on identity, permissions, and separation of data. If many customers or departments are using the same broad environment, the service has to keep one group's data from appearing in another group's space. That is why account handling, role settings, and access permissions are such important parts of cloud support. A beginner should understand that cloud security is not only about keeping outsiders away. It is also about keeping each tenant properly separated inside the shared environment. When permissions are set badly, the problem may look like a sync issue, a missing file issue, or a login issue, but the deeper cause may really be that the service is not placing the user in the right logical space. That is a very practical lesson because it helps technicians remember that cloud support is often about asking who the user is, what space they belong to, and what they are allowed to see rather than focusing only on the device they happen to be holding. File synchronization is another cloud behavior that matters a great deal in daily support because it shapes how people experience their data across different devices. File sync means a service is working to keep the same file or folder content consistent in more than one location, such as a laptop, a phone, a tablet, and a cloud account. A beginner can think of this as keeping multiple copies lined up so the user can start work in one place and continue in another without confusion. That sounds simple until something goes wrong. If sync is delayed, interrupted, or conflicted, users may see one version on one device and a different version somewhere else, and that quickly turns into fear that work has been lost. Technicians need to understand file sync because many user complaints are really sync complaints expressed in plain language, such as the file is missing, the old version came back, my changes are not showing up on my other device, or someone else cannot see what I saved. A very important beginner point is that file sync is not the same thing as backup. Sync is about keeping files matched across locations, while backup is about preserving recoverable copies in case something is deleted, damaged, or changed in a bad way. This distinction matters because users often assume that because a file is in the cloud, it is automatically safe in every possible sense. In reality, a sync deletion can still remove the file from multiple places if the service is doing exactly what synchronization is supposed to do. A technician who understands this difference can explain problems more clearly and avoid creating false confidence. If a user deletes the wrong file and the deletion syncs everywhere, that does not mean sync failed. It may mean sync worked exactly as designed. The real question then becomes whether the service also has backup, version history, or recovery features that help undo the mistake after synchronization has already spread the change. File sync problems often come from timing, connection quality, conflicting edits, or account mismatches rather than from true file corruption. A laptop may have been offline and not yet uploaded the newest changes. A phone may still be showing cached content. Two users may have edited the same file at nearly the same time and created a conflict. One device may be signed into the wrong account or looking at the wrong shared folder. These are very common cloud support situations because the service is trying to keep many copies and users coordinated over time, and that coordination is not always instant. A beginner technician should learn to ask plain questions such as where the file was last changed, whether the device was online, whether more than one person edited it, and whether the user is looking in the right cloud location. Those questions often solve the mystery much faster than treating the issue like random file disappearance. These cloud ideas also connect closely during troubleshooting. A user may report that files are taking too long to appear, and the cause might be a sync delay, a service slowdown during high demand, or a partial availability issue in the cloud platform. Another user may say their app is slow only at busy times, which may point toward elasticity or overall service load rather than a local computer problem. A department may report shared access problems, which could involve permissions in a multi-tenant environment rather than missing files or broken devices. The beginner lesson is that cloud symptoms often overlap. A slow service, an unavailable feature, and a delayed sync can feel very similar to the user even though the underlying cause is different. That is why technicians have to think carefully about patterns, timing, scope, and whether the issue affects one user, one group, or many users across different places. One of the best habits a beginner can build is to separate local problems from service-side problems as early as possible. If one device is misbehaving while the service works fine everywhere else, the issue may be local to that machine, network connection, or account session. If many users are seeing the same cloud issue at once, the problem is much more likely tied to availability, shared infrastructure behavior, or a service-side change. If the complaint appears only after a user switches devices, goes offline, or edits from two places, file sync becomes a stronger possibility. If the service slows down during predictable high-demand windows, elasticity and scalability become more likely areas to think about. This does not require advanced cloud engineering knowledge. It requires a clear support mindset that asks who is affected when it happens, whether it changes by device or location, and whether the service is behaving more like a local app problem or more like a shared cloud service under strain. By the end of this topic, elasticity, availability, multi-tenancy, and file sync should feel much more practical and much less like cloud buzzwords. Elasticity helps services respond to changing demand. Availability helps keep those services usable and dependable. Multi-tenancy explains how many customers can share one larger cloud environment safely. And file sync helps users see consistent data across devices and locations. These ideas matter because they shape what the user experiences every day, from whether an app stays responsive during busy periods to whether a changed file actually appears where the user expects to find it. When technicians understand these behaviors, they can troubleshoot cloud problems more calmly, explain service issues more clearly, and avoid wasting time looking in the wrong place. That is a big part of good cloud support at the beginner level, because once you understand how the service is supposed to behave, it becomes much easier to notice when it is behaving badly and much easier to decide where to look next.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.